Good afternoon, everybody. Now, the today lecture is basic organic reactions. बच्चों लोग आपको मालूम है कि ऑर्गेनिक रिएक्शन 11, 12 और बीएससी स्टूडेंट को बहुत ज़्यादा कठिनाई जाती है, क्योंकि ऑर्गेनिक रिएक्शन को पहले अपने को समझना पड़ेगा. जब हम ऑर्गेनिक रिएक्शन को समझेंगे तब हमको उसका मैकेनिज्म और उसका अदर जो पार्ट है रिएक्शन का वो अपने को समझ में आएगा. सपोज दिस ए एंड बी आर द रिएक्टेंट्स, इट्स गिव प्रोडक्ट, इट मे बी सी और सी प्लस डी. नाउ ए एंड बी आर द टू रिएक्टेंट्स and product is either C or C plus D. So in these reactions what happens, the reaction conditions is very important. Reaction condition is very important. Now for these reactions requirement is that first is the solvent. Solvent is very important role in the reactions. The role of the solvent is what? To dissolve the A and B in this solvent. Solvent may be protic solvent, non-polar solvent, it may be other solvents or non-polar solvents. This A and B can be dissolved in this solvent. When A and B dissolve in this solvent, what happen? They A and B collide to each others, and in this case what happen, the carbon hydrogen bonds or carbon oxygen bonds may get loose due to the presence of the nucleophile or base, nucleophile or base. This is very important part in the reactions. Means when a reaction is carried out, the solvent is very important part, nucleophile or base is also important parts. Number third is a catalyst. Catalyst is also important parts. What is the role of catalyst? The role is that when A and B react to each other, at that time the rate of reaction can be increased due to the catalyst. Rate of reactions increase. Rate of reaction increase. Nucleophile. Role of nucleophile is, suppose solvents, roles, nucleophile, base and catalyst. Now the nucleophile and base, suppose C double bond O, CH3, CH3. This is a keton. In keton, the nucleophile means denoted by the Nu minus. Or base may be OH minus or NH2 minus. These are the base, very strong base. The nucleophile role is that when these nucleophile attack on these carbon atoms, at that time there are one pi bond, one sigma bond. The pi bond is a weak bond. They can be shifted towards the oxygen atom, due to the oxygen is more electronegative atom than the carbon atoms. The structure becomes CH3 CO minus, here Nu nucleophile and this CH3. The nucleophile can attack on these carbon atoms, functional carbon atoms. The pi bond is weak pi bond shifted towards the oxygen atoms. The oxygen gets negative charge and carbons gets positive charge. We cannot share here, but nucleophile is attached due to the carbon charge is removed. And And the role of base is what? Role of base is that this again keton, the role of base is that this OH minus ions can attract the proton. Proton means what? H plus ions is called as a proton. These protons can be abstract or removed from these carbon atoms. This carbon atom, due to these carbon groups attached to this carbon, or it may be this carbon are equivalent to each other. They can remove these hydrogen atoms and we can get the structure like that: CH3, C, double bond O, CH2 minus. This is called as an anion, carbanion. And this is also act as a nucleophile, and this nucleophile also get in resonance structures between these oxygen atoms and these carbon atoms, and these force are attack on the another reagent. It may be, we can show that A and B or A, other reagents, and the reaction takes place. Now we can here see that nucleophile roles attack on the carbonyl carbon, because this carbon is electron deficient, and the here base is abstract the proton from the functional this CH3 groups. It's the acidic, this is the acidic hydrogen. This is the acidic hydrogen. The role of proton is, role of base is to abstract the protons. We know the solvents, role of solvent is dissolving the reactants. There are two types of the solvents: non-polar solvents, polar solvents. The non-polar solvent is benzene, hexane, CCl4, carbon tetrachloride. These are the non-polar solvents. Non-polar solvents cannot be stabilize the ions. If A and B are the reactants, at that time they get in the form of the ions by attacking the nucleophiles or nucleophiles. At that times the percentage of ionic character is very less. At that time we use non-polar solvents like benzene, hexane or carbon tetrachloride. Now second type is polar solvents. Polar solvents having also two types: polar protics and polar aprotics. Both solvents are polar in nature, but difference is that polar protic solvents generally form the hydrogen bond with the reactants. Generally polar protic solvents can form the hydrogen bonds with the reactants. Since this, suppose this C double bond O, at that time what happen when nucleophile attack on these carbon atoms? What happens? These O minus and these plus charge are developed on carbon atoms, and these OH minus ions can form the hydrogen bonds with solvent via internal hydrogen bonding. Generally these are the inter hydrogen bondings. So polar protic solvents are stabilize the charge ion compounds. It may be either A or B, depending on the A reactance is here the charge or not. Now these polar aprotic solvents, the example is that dimethyl sulfoxide. Now this DMSO, dimethyl sulfoxide, acetone, acetonitrile and dimethyl formamide, these are the polar aprotic solvents. These are also having the polar in nature, but they cannot form hydrogen bonds with the reactants like this. There is a no hydrogen bonding in polar aprotic solvents, but these solvents are very important in stabilize some ions also, and these solvents are generally used in pure organic compounds. Suppose A and B are less in polar, at that time we can use this diameso acetone or acetonitrile solvent to carry out the reactions. Now our third part is the catalyst. What happened in catalyst? Catalyst increase the rate of reactions. After the completion of the reactions, they separate out. They cannot be involved in the reactant or product. Means catalyst only the increase the rate of reaction. In what happened in the catalyst? What is the role of catalyst? Suppose this is the y-axis, this is the x-axis. These are the reactant R. This is the graph, and here the product P. This is the x-axis is the rate of reaction, and this is the energy. On y-axis energy. The catalyst role is that if without the catalyst, suppose this reactant is converted into product P, but if we use catalyst, what happen? This is a transition state or activated state. If you use catalyst, the reaction path is like that. Means this is the transition energy is decreases up to this level, and the role of catalyst is to carry out the reaction very fast using our activated state or transition state get lower at the side. This is a y-axis, this is a x-axis, this is a rate of reaction on the plot on the x-axis, and energy is on the y-axis. A and B are the reactants, and here is the product. The energy of the product is less than the reactant, that is equilibrium is shifted towards the product. Now what happen when we use the role of catalyst is that each and every reactions can going through these steps. This is a transition state or activated state. Each and every reactions going to these states, but if you use the catalyst, at what happen in catalyst, the role of catalyst is that to decrease this transition energy level to this point, or it may be decreased also in this type. That is the reaction time is decreases. This A to this transition state require much time than this or than this. That is the role of catalyst to decrease the transition state energy levels. The catalyst, when the completion of the reaction, the catalyst is not consumed, we get it as it is retrieved back as it is. That is, catalyst is reusable, again reusable. It is not consumed in the reactions. Now we cover these points in chemical reactions: role of solvents, dissolving the solvents; role of base to attract the protons; nucleophile to attack the carbonyl carbon atoms; catalyst, rate of reaction increases; temperature and pressure is also very important in the chemical reactions. Temperature is increased and pressure is also important in the reactions. Generally this pressure or temperature is used in the nickel H2 or dehydrogenation reaction. At that time the pressures and temperature is very important role in the reactions.